Hey everyone, I want to walk you through Alfred Weber's least cost theory today. Now, I feel really guilty about being away from you guys this close to the AP exam, but I know that if you push yourself, you're really going to be able to make yourself learn this and you're going to be able to not get behind whatsoever. And when I get back, we'll be able to review this and make sure that you guys are good to go. So, our newest model is by Alfred Weber, who is a German economist and geographer. And the model is always referred to as least cost theory, but sometimes we'll also hear it called industrial location theory. And Weber was interested in one thing: where should businesses locate their factories in order to convert raw materials into finished goods? So, our least cost theory is going to be used to predict the location of these manufacturing facilities. Where should we put them compared to the marketplace? Where should we put them compared to the natural resources? Should they be closer to the resources, or should they be closer to the city where they're going to be sold? And Weber looks at three factors when he's creating his least cost theory. He looks at labor. So what that means is, how much is he going to have to pay people at each location to be able to work? In an ideal world, Weber would want you to have the lowest labor costs possible. The biggest factor that Weber uses to predict where you should locate factories, however, is transportation. He wants to reduce the amount of money you spend transporting goods as much as possible. In this way, Weber is a lot like von Thunen. He wants to make sure that you're getting the bang for your buck in terms of transportation. The final factor that Weber says is important when deciding where to locate your facility is agglomeration. Agglomeration is just a fancy name for all the benefits of having similar businesses located near each other. For example, in Silicon Valley in California, you're going to have a lot of different tech firms. And so, for instance, you'll benefit from the fact that there will be computer repair companies near there will be a talented labor pool near there. Agglomeration are just all these effects of having similar firms located near each other. And Weber says that that's useful in predicting least cost theory. So we're looking at labor. Can we find a place where we can pay people the least amount as possible? We want to look at transportation. Where can we place this facility so that we will spend the least amount of money in gas? And also we want to look at agglomeration. How are we going to get those benefits from being located near similar businesses? So right here I have an example. We have a resource base and we have a market that are 50 miles apart from each other. And then we have three locations: location 1, location 2, and location 3. So our question is, if you're producing some sort of good from a raw material, do you want to produce closer to the market or closer to where your natural resources are? Go ahead and take a couple of seconds with the people around you. Talk about where you think you should place your industrial firm. Should they be closer to the market or closer to the resource base? If you said closer to the market, you were probably thinking about the fact that it would be easier to get people to labor closer to a place where people are living. And that's a really good point. If you said close to the resource base, you might have thought that land was cheaper based on your bid rent curve. The further away you are from a market, usually the cheaper your land's going to be, and so maybe that's a good indication to take into effect. However, the important thing here is, if it's a straight line, it really doesn't matter where you produce your product. You can produce it at either location 1, 2, or 3, and it will probably be fine. There are exceptions to that, and Weber talks about that pretty greatly. And the first exception would be something like a brewery. So assume that water and grain are the only two ingredients that are used to produce beer. If that's the case, would you want to locate your brewery closer to the town where you're going to be selling the beer? Or would you like to locate closer to the spring water and the grain fields where you'll be getting the raw materials? Tell the people at your table, which one would you do? Would you locate it closer to the town or closer to the raw materials? If you said town, then you agree with Weber, and here's why. Weber says that it's easier to move spring water and grain than it is to move bottled beer. Again, this is a lot like the von Thunen model that we saw, right? We saw that we wanted to move things that got bulkier closer to the town. We wanted those to be produced closer to the town to maximize transportation. And that's what happens here. If you ever are getting anything that's going to get bulkier, then we want to produce it as close to the town as possible so that we can be transporting the base materials. What about a steel factory, though? So assume that steel is made out of just coal and iron, and we use coal and iron to make the same amount of steel, would we want to locate close to the resources or close to the market? If you said close to the resources, you are absolutely right. In this case, it's much more expensive to move both iron and coal than it is to move the same amount of steel, right? We would be moving 2,000 kilograms instead of just moving 1,000 kilograms. So we want to process that as quickly as possible so that we can move the cheaper item, which is steel in this case. So unlike a brewery, which we'd want closer to the market, we'd want to make coal and iron into steel closer to the resources. So we call these two different products bulk gaining or bulk reducing products. So if products get bulkier after they are turned into their final product, we call them bulk gaining. And we want to produce bulk gaining products closer to the market because we don't want to create a system where we're transporting this bulky good instead of transporting these easier raw materials. So in the case of our brewery, again, much easier to transport water and wheat than it is to transport bottled beer. That would be bulk gaining, and so we want to locate close to the market. Bulk reducing products are any product that becomes easier to transport after it's made. So any bulk reducing product is usually going to either weigh less or be less cumbersome than its raw materials. And so we want to produce that as quickly as possible so that we can transport the lighter or less bulky materials. So bulk reducing products should be located closer to the raw materials instead of to the market. So really quickly, let's think about potato chips, and assume for the purpose of this that potato chips are made using just potatoes and salt. Would you rather locate your potato chip factory close to the resources or close to the market? Talk to the people around you about it. Now, if you were thinking about potato chips, you might have correctly guessed that you want to locate your potato chips as close to the resources as possible. Potato chips weigh a lot less than potatoes, and so if you're going to produce this product, we might as well ship the potato chips, which weigh much less, instead of shipping the heavy potatoes. So if you said close to the resources, very, very good job. You're starting to really understand what Weber's talking about. Here we see three models. In this first model, we have an item that doesn't either gain or lose bulk during production, and we can see the ideal space to locate it would be sort of right in the middle of this triangle, directly between the two resources and the market. Item B right here, we have an example of a bulk reducing item, right? We have an example of an item like those potato chips or like that steel that's going to get less heavy, and so we want to produce it closer to the resources right here. In item C, we see a model for a bulk gaining product. We want to transfer that as close to the market as possible in order to reduce the transportation. Remember, this is like our bottled beer example. A couple of assumptions of least cost theory. These are fairly basic model assumptions. The least cost theory assumes one market. It assumes an isometric plane, just like von Thunen. All land is flat, equally easy to access. It ignores traffic and assumes that there's an equal quality of roads. And it assumes that there's an equal cost of land. Now that you've heard about this theory, I want you guys to make sure that you really understand it. Use Crash Course or your textbook if you need to. Make sure that you're being curious and you're being creative and pushing yourself to really do this work. I'm going to give you out a handout that's going to go over this in more detail, and I'd like you to fill those questions out for me. Thank you guys very much, and I look forward to seeing you next week.